Okay, general math students, in this video we're going to discuss Hamiltonian circuits and paths, and then we're going to do an example where we're going to find some Hamiltonian circuits and paths through a network, but at the same time we're going to find some Eulerian circuits and paths if possible, and we're going to contrast and talk about the difference between Hamiltonian and Eulerian circuits and paths. So a Hamiltonian circuit is where we visit each vertex in the network once and only once and end up where we started. So here we've got A, B, C, D, E back to A. So in this circuit we go to every vertex once. A Hamiltonian path, well, once again we go to each vertex, but we don't end up back where we started. We end up somewhere other than where we started. So in this one we've started E to A to B to D to C. So we've been to every vertex there, but we've started at E and finished at C. So there are all sorts of different Hamiltonian circuits for different networks. If looking at this one here, we could just do this as a circuit, A to B to C to E to D and back to A. D, E, A. Just to contrast that though, we could of course do this. A to D to E to C to B to A, so basically the other way around. That is also a Hamiltonian circuit, just a different one. So a couple of different options there. Now Hamiltonian path from A to C, we're going to start here and finish here and go to each vertex once. So we could do this, A to D to E to B and then C. Oops, to B and then C, like that. So there's an option there, and I'm sure that you could find something else. You know, you could do one like this perhaps, where go to B to E to D and then to C like that. So different options there when it comes to Hamiltonian circuits and paths. Okay, so looking at this question here, you might want to pause the video now and then I'll have a go at them. Of course, we might end up with different answers here for some of these because there might be more than one option, but that's okay. Okay, go ahead and try it. Righto, a Hamiltonian circuit starting and finishing at A. I'm just going to keep it simple. Just go all the way around the outside. So there's mine. An Eulerian circuit starting and finishing at A. Did you find one? Well, I'm worried if you did because it's not possible. And that's because there are two odd vertices. E and D are both of degree 3. The others are all even. We've got two odd vertices, so it's not possible. But those two odd vertices is what makes this Eulerian path possible. We've got to start at either of E or D, but we could do something like this. Let me try. Start here, go around this way. Yep, that works. I didn't cross any edge more than once, and they were all crossed once. So what was that? That was E to A, to G, to F, back to E, onto D, and then C, then B, then A, and then we end up at D. Now, there are other Eulerian paths that would exist, but whatever Eulerian path you have, it must be starting at either E or D and finishing at E or D. It's got to start at one of those odd vertices. Hamiltonian path from E to B. Okay, so now first thing, remember E for Euler, E for edges. So the Eulerian circuits and paths are the ones where we need to cross every edge once. When it comes to Hamiltonian, that's for vertices once each. So what could we do? We could go E to F, to G to A, to D to C to B. You might have a different one to me, but as long as you go to each vertex once and only once, you're okay. A path from G to B. How about this? And then there. That'll do. G to F to E. So you might once again have something different to me. If you just want to check it and make sure it's okay, get me over in the classroom and I'll have a look at it with you. Okay. What's the difference between a Hamiltonian circuit and an Eulerian circuit? Well, a Hamiltonian circuit goes to each vertex once only. An Eulerian circuit goes to each edge once only. So, like I said, think E for Euler, E for edges. Okay, so go ahead and try the questions in the description for the video.